Hello guys and welcome back to the channel. So this is episode 4 of our 5 item job lot for £50. So this is the 4th device to fix that's faulty. So this one's a Harry Potter photo and video printer.
You're a wizard, Harry.
And we've got a sticker from the person who sold this to me saying it's faulty, it's not powering on. So this could be either really easy or it's going to be something that's convoluted. But yeah, never fixed something like this before, so this could be interesting. So I have bought as well to accompany this some zinc paper. So this is apparently what you need for these type of printers to get to print. But you get 10, and this is expensive stuff. So I'm guessing just like printers where they make no money on the printers, they make it on the consumables, which is i.e. the paper or the ink. Same with this. So this was nearly £10 just for 10 sheets, which is very expensive. So yeah, that's with it as well. So if we get it working, we can actually test it. If we get it turning on, we can test it with paper. Right, let's get to it. Let's get it unboxed. We've got a charging lead, so USB 5 volts, and we've got a micro USB. Okay, and this is the device. There's no screen, so I'm guessing it pairs up to your device, and then you do all the inputs from the device, the phone. So we've got the power button here. Let's push and hold. So we've got a battery symbol, we've got a USB symbol for the port, charging port. We've got 2 arrows going around, so I'm guessing that's maybe a loading light LED to say it's doing something.
Wrong, 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 wrong. Wrong, 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 wrong.
Let's check it for power. Right, no power straight away. So let's check for current draw on the device. Okay, so you do get a charging light. We pull in 5 volts and around 0.25 amps. So I've left it for sort of 10 minutes. It's hovering around the same sort of current. So either the battery is getting to its top voltage and that's why it's only at 0.2 amps, or it's not doing much at all. The charge light's not gone out. I assume we're at our top voltage on the battery inside. So again, let's just unplug this. It's been charging up for a little while now. There should be enough voltage in there now. So push and hold. Nothing. Let's do a long hold. Nothing. Let's get this out of the way. It just shows you inserting photo paper. So it looks like a slide. Slide the lid towards the back of the printer to open. Slide the lid. Oh, okay, that was easier than what I was doing. I was being an absolute idiot. Unpack included photo paper, insert. Ah, so it comes with paper and I already bought some. I just wasted £9. Check that first, shouldn't I? So it comes with paper. Ah, what an idiot. Right, well, we need to get this apart anyway, so let's get rid of all the paper. looks interesting. It's quite complicated. The various gears and little motor. So we do have a lithium-ion battery, 500 milliamps. Normal voltage, okay, it's quite high, 7.4 volts. Charging voltage, 8.4 volts. So maybe it's two in series, maybe 2 cells in series to get that voltage. I guess so, because we've got on this connector, we've got 2 positives and 2 negatives. So that must be 2 cells in there to make up one pack, one battery pack. Let's get this shroud off. Oh, that's interesting. Is that 2 screws missing there? Don't tell me someone was taking this apart before.
No! God, please, no!
I hope not. Yeah, it's like 2 machine screws been taken out. Right. Also, we've got a black screw and just a steel screw. I wonder if they've been put in the wrong place. I hope it's not been taken apart before. I mean, 2 screws missing, that doesn't bode well, does it, straight away? You don't know what someone's done prior. So that's just a shroud, or a shield, perhaps. Is that for noise, perhaps, maybe? I don't know. Electrical noise? Over there. This is quite compact. Lots of ribbon cables. We've got 1, 2, 3. Let's get these disconnected. And we'll get the board out with the battery. Battery disconnected. It feels like 2 cells right in the middle. There's a seam, so I'm guessing it is 2 in series to get that voltage. And let's get this board out as well. There we go. So that's the circuitry. The rest is the printer assembly. The rollers and the gears, the motor. Right, set that to the side. Let's get the multimeter and measure our voltages on this battery. Set to DC. I'm almost tempted to see how it's connected in there. We do have the voltage that was rated on the rating plate on the device. So even on here it says 7.4 volts. So it goes to ground. And then on the positive 7.77 and then 7.77. So I think the 2 cells are joined together in here. So they must be in series. And 7.4 is a normal voltage. I guess in 7.7 is the top high end voltage. Now we're getting towards the top voltage for being fully charged. But anyway, we've got battery. We've got power. Let's plug it in and measure across this connector. I'm guessing the yellow is to do with maybe balance charging perhaps. So outside pins. So we have power on the board. Let's see if it turns on with the other stuff disconnected, because there might be a problem with this part of the circuit here that's causing this not to turn on. So everything disconnected bar the battery, does it turn on? This is the power switch here. Nothing. Nothing. Can we test that switch at all? So I'm going to have to get this under the microscope because that is tiny, really hard to see. Okay, so that's now under my microscope, and we have the switch there in view. See if it might be focusing. So continue across these two and these two. What if they break when the button's pushed in? Pushing it in. Right, it's these pins going across that are the signal. The switch is closed. So that switch is in, out, out. So that probably means this switch works fine. Let's just inspect this board on this side and inspect the other side. See if there's anything. So here we have the micro USB charging port, the reset switch. Quite hard to push in those buttons. Various resistors, capacitors, chips, another chip. These voltage regulators or transistors. Big capacitors there. Some sort of IC there. No idea what this is. Capacitors. Big old chip here. Another chip. Actually, what's under this? Is that a thermal pad? Perhaps, maybe? Let's leave that there. Is that an inductor or crystal? Is that a capacitor? A switch for the cover, back cover. What are these things? I'm not sure what these are. These, sorry. G4. It's quite a populated circuit, isn't it? Quite a lot going on. I can't see nothing on this side that strikes me. Let's check the other side. Flip it over. Right, so we've got the connectors for the ribbon cables, some little capacitors, another connector for a ribbon cable, more resistors and capacitors, got a crystal there, lots and lots of capacitors, Jesus Christ. This is just, they've just used every square inch of this board, haven't they? Got status indicating LEDs there. We could always put a diode mode and test these LEDs as well. We're know that one works for the charging. Right, nothing striking me at all. Where do we even start with this? This is just... Fortunately I lost the footage prior to this, but I've identified various shorts on this side of the board. There's a few more elsewhere. This is where the most are concentrated. All the ones that are circled red are shorted to ground, and on the other side of the board is that big chip which I've identified as the I/O for the printer. So that's the various inputs and outputs. So here we have the chip in question that's causing all these shorts on this board. Again, I forgot to capture the footage of this, but here's just a picture for now. So the manufacturer's a Connexant, and the model is the CX92122-51Z. Cannot find this anywhere. I'm guessing it's some sort of proprietary chip. It's not obviously available for the likes of me. You know, if I was a manufacturer or supplier, maybe I could get hold of it. Yeah, the only one I can find similar is the CX92121, but I can't find a means to buy it either. And it's not financially viable to buy a donor machine to rob that chip off, unfortunately. That chip is obviously faulty. We've tried to reflow it, re-tin the pads on the chip itself and the board. We could reball it. So that is one thing I've got coming along the way, is I bought a reball kit with a jig and stencils and balls of various sizes, so for next time we need to do something like that, we can. But regardless, that chip itself is not available for me to purchase. Unfortunately, we're just going to leave it as it is. So I'll keep it. It's not a total loss. So we've got a battery that we can use, repurpose. There's components on that board that we can reuse, like capacitors, resistors, connectors, switches, LEDs. Stuff that we can harvest for other stuff later in the line. And if we do come across another one, then we'll have two to get one working. So not a complete loss. That's that one done, number 4. So that one's not repairable, unfortunately.
All around me are familiar faces.
So the next episode 5. So this is the 5th item out of the 5. Devices for the job lot. We've got a Kodak Printomatic, it's a digital instant print camera, so I think it takes pictures and prints. So this one's listed as faulty, does not power on, no paper. Again, we've got the same brand, Zinc, Zero Ink. I keep seeing, I saw that on the other printer as well, that we just tried to repair. But I think it takes the same paper that I purchased for the other device, so that's a good thing at least. But yeah, we'll take a look at this at the next episode, and hopefully we can sort this one out. Until next time.